So first we're going to talk about the properties of parallelograms, and we'll use these properties to solve problems about the parallelograms. So first off, a parallelogram, as we talked about before, is a quadrilateral where opposite sides are parallel. And that's the definition. Oh, that's a highlighter, sorry. Okay. So the definition is where opposite sides are parallel. So really that's all you need to know to identify a shape as a parallelogram, that the opposite sides are parallel. So its first property is the same thing. We know that opposite sides are parallel. So we're writing things are parallel to show on this picture. We write arrows like this. These arrows show us that if they have the same number of arrows, then those sides are parallel. So how can we use that to solve problems about parallelograms? Well, we have to kind of go back to our parallel lines and transversals. So if you remember, we have parallel lines and transversals, and this right here you don't have to copy down, but if I have my parallel lines and my transversal, where they meet right here, these angles are alternate interior angles, and those angles are going to be congruent to each other. Same with these angles right here. The blue ones will be congruent to each other. And then I can do the same thing with the other sets of parallel sides. So this angle is going to be congruent to this angle. And then these last angles will be congruent to each other as well. So in order to solve problems like this, we need to know that angles that have the same colors are congruent. So if I'm given that this angle right here is 50, then I know this angle over here is 50. If this angle over here is 30, then this angle over here is 30 as well. Okay, we also know that opposite sides are congruent. So we mark congruent by our little hash marks. So 1 mark, the same, they're congruent. 2 marks, the same, means that they're congruent. How to solve problems like this? We would set the sides equal to each other. That's a U in case it doesn't look like it. Okay. Also in a parallelogram, opposite angles are congruent as well. So this whole angle that I'm going to mark in red is congruent to this whole angle I'm going to mark in red. This whole angle in blue is equal to this whole angle in blue. So to solve problems like this, we would set opposite angles equal to each other. Okay, so we have 2 more properties. Consecutive angles are supplementary. If you forgot what supplementary means, you can go back to your definitions that we took last class. Supplementary means that they add to equal 180 degrees. So consecutive angles, if you've forgotten, are angles that are right next to each other. So these would be considered consecutive angles. So these angles would add to equal 180 degrees right here. These angles would add to equal 180 degrees as well. But you need to know that consecutive angles, not just from the left and the right, but also these two will be considered consecutive angles, and the ones at the bottom will be considered consecutive angles, okay? So consecutive angles, to solve for them, we would set consecutive angles equal to 180. Okay, and our very last property is diagonals bisect each other. So our diagonals, I'm going to highlight in red. These are my diagonals. They bisect each other, so they have the same, when they cut, they have the same measure. So these two segments are congruent to each other, and these two segments are congruent to each other. So it kind of depends on what you're given in the problems. How to solve these, there isn't necessarily one way. If you're given this part of the diagonal and this part of the diagonal, then maybe you would just set them equal to each other. Sometimes you're given this part of the diagonal and then the whole thing to solve for x. So it kind of just depends on what you're given. So if you're given 2 halves, so 2 halves of a diagonal are equal to each other. Or 1 half and 1 whole, you would double the half one and set equal to the whole. So let me explain a little bit more just by talking. So say I'm given this half and this half, I would set them equal to each other. Or if I was given this half and then this whole, I would double this half, because doubling this would be the same as this whole diagonal. And then I would set it equal to the whole diagonal that I'm given. And that would allow me to solve for x. Okay, so we're going to do some examples on how using these properties with parallelograms. Okay, so this first problem, we have to actually draw our picture. So we have to draw what a parallelogram looks like. So something like this. And we also have to remember how to label a parallelogram. So we can start at any quarter, but remember I have to follow the shape, A, B to C to D. If I don't draw my picture correctly and still try to solve the problem, I'm going to solve it wrong because my letters are going to be in the wrong place. So we know A equals x and D is 2x minus 3. We want to find the value of x. So it gave us angle A and angle D. Angle A and angle D, angle A and angle D are consecutive angles because they're right next to each other. So we know consecutive angles add together to equal 180 degrees. So that's how we solve it. We do x plus 2x minus 3 equals 180 degrees. So let's combine our x's. So we have 3x minus 3 equals 180. Add 3 to both sides. These will cancel out. 3x equals 183. And divide off my 3. And x equals 61. That's the value of my x on that example 1. Okay, let's move on to example 2. Again, we have to draw a parallelogram. So again, we can start at any letter, any point, but I have to go in order. So let me start here. X, Y, Z, W. And it has diagonals, X, Z, and Y, W. So this is a way to check yourself. So X, Z, oh, my diagonal, yes, I have a diagonal X, Z, and I have a diagonal Y, W. So if you don't end up having those diagonals, then you probably drew your problem wrong. That intersect at point A. If XA is 3M, and ZA is 5M minus 4, find M. So on this one, it gives us two halves, ZA and AX. It gives us two halves of diagonal. So for two halves of a diagonal, we set them equal to each other. So I have 5M minus 4 equals 3M. I'm going to solve this for M. So subtract 5M from both sides. These will cancel. I get negative 4 equals negative 2M. Then divide off negative 2 on both sides. These will cancel. Negative 4 divided by negative 2 is 2. So M equals 2. Okay, and on our very last question, we have a picture already. We're going to figure out what X, Y, and Z is on this picture. So, first off, I know that opposite angles in parallelograms are congruent. So if this angle is 120, then the angle opposite will also be 120 as well. I know that consecutive angles add up to equal 180 degrees. So, this angle right here and this angle right here, they equal 180 degrees. So, I know that 120 plus 35 plus x will all add to equal 180 degrees. So that is 155 plus x equals 180. Subtract 155 from both sides. And x equals 25. Okay, so we know x is 25. Okay, and last, we can go back to let's see here. Since we know that this is a parallelogram, all of our shapes in this section are going to be parallelograms. We have to remember that the lines are parallel right here. So if these lines are parallel, this is my transversal, then these angles right here are going to be congruent to each other. So that means that y equals 35 degrees. So these are examples on parallelograms.